and today I'm planning out a foam machine. I tried that gluten and there's nothing. So I'm gonna have to go based on patents, reading patent specifications for foam machine related patents, and also reading about foam itself on Wikipedia as part of my strategy. The main thing I want to learn here is, does every type of foam get made in the same way? And then if I can find information about a foam that isn't the kind of foam I'm trying to make, but it's still information about how to manufacture a machine that makes that kind of foam, then I could still apply that to the type of foam I'm trying to make. I need to be able to mass produce foam for one of my other businesses, because buying foam is very expensive because of the shipping. It costs like $150 to have it shipped. And basically you're shipping air, because it's just plastic with little air bubbles in it that makes foam. So I'm paying $150 to have air shipped to me. And that's stupid. I'd rather be able to take buy a 5-gallon bucket of pellets and be able to make thousands and thousands of dollars worth of foam just based on the plastic pellets. Plus, I could use recycled plastic from a junkyard or wherever, and melt it down, make my own pellets, and then use that to make foam. So that's another way. And I could basically make the foam for free that way. And I'm spending a lot of money per product I sell online just on the foam. If I can cut the price of the foam to zero, I'm going to be able to make like 20% more profit per sale. Imagine if you had a company, you can increase your products by 20% per sale. That's a huge increase in profits. But I need to create this machine, and I've been wanting to create this machine for years now, but I just kept running into problems and kept giving up. But this is another one of my attempts to really, like, as time goes on, I'm becoming more and more determined to make my own machine, and I'm just deciding, like, let's try to go for it again, continue to learn. I think I might... Guys, you gotta admit, it'd be pretty awesome for me to have a foam machine in my room, wouldn't it? Like, dumping in pellets, and the machinery is turning, and I've learned all about the electronics and motors and stuff, so that's probably why I'm willing to go at this again. A year and a half ago when I was researching this stuff, I was more interested in buying a machine that could do it, but with my increasing knowledge of casting and fabrication, electronics, microcontrollers, motors, and controlling of large DC motors using Arduino, power supplies, all of that knowledge I believe now has me at a point where I can actually make industrial quality machines that I can use for production of products that I can sell. And starting out, obviously, products I'm already selling, to cut the cost down by producing in-house is my first aim. But in the future I might produce other products. As a side benefit, I could even ship the foam as a side business. I could sell foam as well. So that's a bonus. This is it! This is it! Liquid plastic foam. This is a patent for that. I'll be able to look at the diagrams of the machine, read it, and understand it, and produce this machine. A patent is meant to enable people skilled in the related arts to be able to make the machine described in the patent. So if this patent does its job, it will enable me to make the machine that was described in this patent. This patent was made in 1961. And it is my job to convert this to reality, make my own foam machine using it. I'm very excited. I think we got it, guys. I'll show you guys what I want to make. The product. This is hard, but it still can flex a little bit. This is pretty high density. I'd want it like more gaseous, less plastic, so it's lighter in weight. I don't need it to be this strong. But this is the gist of what we're going after. And I'm gonna make this, guys. Goodness, I mean, this thing costs like, well, let's see. This is $12 right here, $12. And that's considered cheap. That's at bulk discount pricing, whatever. $12 shipped to my house. But I want to be able to produce this piece of foam for, let's say, free. And then sell it. So that's why I need to make a foam machine. We can do this. We can do this. I will not take failure as an option. And it ain't gonna be easy. Whoa.
Dr. Ann Helmenstein for About.com, and this is my assistant, Sam. We're going to show you how to make a baking soda and vinegar volcano.
This volcano is a model volcano for science projects. You form the cone of the volcano around a bottle, then mix non-toxic kitchen chemicals to cause the volcano to erupt. The cinder cone of the volcano is formed using clay or dough. You'll need a lot less volcano material if you make a general volcano shape out of paper and cover it with clay. You will need warm water, baking soda, liquid dishwashing detergent, and vinegar to make the lava for your volcano. You can color the lava by adding food coloring or mix. To cause an eruption, fill the bottle most of the way full with warm water. Warm water produces a better eruption than cold water because the higher temperature increases the rate of the chemical reaction that makes the lava. Add a squirt of dishwashing liquid and a few spoonfuls of baking soda. When you're ready to start the eruption, pour vinegar into the volcano. You can color the vinegar with food coloring or powdered drink mix. The baking soda is sodium bicarbonate. The vinegar is weak acetic acid. The two chemicals mix together to form carbon dioxide gas. The carbon dioxide tries to escape the volcano and must be saved.
Oh, it does have a lot to do with foam, because the foam machines I'm researching the patents on use chemical reactions to produce the bubbles, which provides the bubbling within the molten plastic. I'm finding that none of the patents involve injecting compressed gases into the plastic. All of them are involving mixing chemicals that are going...
Spoonfuls of baking soda. When you're ready to start the eruption...
Caboose, you're not understanding. These chemicals, if combined with molten plastic and mixed together, will still expand into bubble form, separating the molten plastic into bubble pockets. And then when it hardens or gels, the result will be a hard foam, which could be used as a pool noodle, for example. You need to have a chemical reaction that generates gases in your fluids as they're ejected from the machine after they're mixed together at the correct pressure.
You can color the lava by adding food coloring or powdered drink mix.
It's not a theory. I'm reading patents, U.S. patent after U.S. patent after U.S. patent. These are actual patents, and they have actual drawings of actual machines and actual blowing agents. In this case, the blowing agent would be a chemical reaction. It talks about blowing agents. A blowing agent is a substance which is capable of producing a cellular structure by a foaming process. Now, these kid experiments are a foaming process that can produce a actual cellular structure in molten.
It's not real good.
Here, have a
Alright,
look.
yeah, so there you go.
Okay.
Do safety first, yeah?
Ready.
Alright, so I'm going to put probably about 3/4 of a cup in there. Alright. So this is for the grown-ups to do. Alright. Then, an interesting ingredient. Alright, we take the goggles off. Yeast. Dry yeast, believe it or not. This is going to be our catalyst. Hydrogen peroxide is H2O2. So it's like water, but with an extra oxygen. We're going to try to get that oxygen to come out. So, 1 tablespoon of yeast into this little cup here. There you go.
Yes, there
And
we
then
go.
3 tablespoons of water into that. There we go. And take a note at home, it's on the website.
All right.
There you go, stir that up.
Okay.
Alright, now, while you're doing that, I'm going to add a little bit of dish soap in here. Right, because we got to have the dish soap. And, let's see, let's go for red foam.
Color?
No color. There we go. So, hydrogen peroxide, dish soap, and then some yeast. Now it's getting a little...
Is that how we want
well, there's it kind of chunking up on you there.
it? Yeah.
Alright, so we'll just... That's alright, we're just going to take out the extra here.
Okay.
Alright, we only need the stuff that's all watery. There we
Okay.
go. Alright, now we got the water. After you're going to pour that in there.
I'm going to put it in.
So yeast, yeah, we use our funnel. And
Okay.
hydrogen peroxide, a little dish soap, go for it.
You ready?
There it goes. Let's see if we can get a little more foam this time. Oh, yeah, there we go.
Oh my
And
God.
now that's pretty good. Look at that.
I love this.
That's good television right there. Look at that. So quite a bit more foam on this one.
Quite a bit.
And
I'm not making polyurethane though. I'm making polyethylene, which is very different. You can already buy polyurethane hardener and kits, and that kind of foam is not the kind of foam I want. It's brittle, it's hard, it's not soft and spongy like polyethylene. You can break it in half over your knee. Yeah, polyurethane is absolutely not. That's a crusty foam. You can scratch at it and see powder coming off. Check this out. Sulfuric acid could be considered vinegar. Saturated aqueous solution of sodium bicarbonate. Sodium bicarbonate is baking soda. So basically baking soda and vinegar combined with polyvinyl alcohol. Okay, that's for foam stabilizing. I really don't know what to make of that. But yeah, baking soda and vinegar basically, in fancy words, what he's saying, as the liquid you mix into the molten foam in this chamber he designed. I think I'm going to use mine, I'm going to have mine eject and then fall into my mold of my cylinder, and then it will rise in the mold, producing the final end. How does it work? So basically, you've got a motor and a motor shaft. It turns inside this cylinder, spinning these fins around. These little walls are called baffles. They help agitate the spinning a little bit better. This is a pump, and it pumps molten foam through this tube, inserting it into the top until you fill the container with molten foam. This is another pump. It inserts through here the first of 2-part reactions or reactants that are going to cause the gas to be formed. The first one can be vinegar, and this one can be baking soda and water, which, just like those volcanoes the high school students make, it combines to form basically a volcano, which is going to release carbon dioxide in the foam. And these two substances will mix by these fins going really fast, mixing it all together inside the molten plastic, and they'll start to react and create a lot of pressure, and that pressure is going to force it through this tube into a mold that will create the shape of your foam when it comes out. And the CO2 gas is going to want to expand while it's in the foam, which will create little air bubble pockets in the foam thereby creating the cellular structure of foam. Importing foam from China is expensive, and creating your own foam machine enables you to make foam pretty much with just recycled plastic. You could probably just make foam with any plastic. So basically you can go to a junkyard, get a bunch of bags and stuff, melt it down and make your own foam out of it. But more importantly, you could just buy foam. You can just buy the polyethylene pellets and melt it down and make the foam. And let's say a 5-gallon bucket of pellets might cost you $100, and the amount of foam it would produce would have cost you $10,000. So for $100, you can produce $10,000 worth of foam, as opposed to buying $10,000 worth of foam. You're able to increase your profits on your foam product you sell. I sell foam online already. I've already sold thousands of dollars worth of foam online for one of my inventions, and so that's the point of making foam. But I can also sell the foam separately, individually, as a foam supplier. If I have this machine, I could sell foam like as a separate deal in addition to my product. Whoa. Whoa. That's more like it. 10 pounds, which is close to that other one, for only 20. That other one was talking about 10 or 15 pounds for $90. This one's 10 pounds for 20, which would be, well, it's 33. It's 75% cheaper than the other one. That's a lot better. So if it was 10 pounds can make 10 products. Let's say 10 pounds can make 14 products. And the price is 32. No. 32 divided by 14 equals $2.28 per. $2.28 per product. Now I'm currently paying $12 per product shipped. This is $2.28, so that's $10 more profit per unit. My profit margin for each unit was only like $20 to begin with. Adding another 10 to that, it's a 33% increase in my margins. Plus, if I go direct to stores, my profit margins were a lot smaller. If I sell wholesale, they were only around, like, let's say $15 profit, maybe even 10 profit. Now it's going up to 20 profit. This doubles my profit margins at the wholesale level if I sell through stores. It looks like a marker, but you can see the pellets behind it. They're just clear white pellets. I'm just going to go ahead and do this. To buy pellets, order the reason I'm not going to buy it now is it seems a little bit jumping the gun. I can test with existing foam, melt it down, and then test the machine. When I get the machine working, then I'll buy a bunch of pellets. There's no reason to buy pellets right now. I wanted to land upon the research success. I wanted to be able to say, I got it. I can do this. I have the knowledge now to do it. that's the first step, and that was a major step. It took me many, many hours, a lot of research, but I finally have gotten to that point where I know what's involved. I have an intricate understanding of how to create the machine. Now it's going to be a matter of weighing out in my mind everything I'll need to make the machine and slowly purchasing the parts and fabricating it. I'm going to break it down into many small steps. It's going to be a multi-month project. I'd like to start it maybe sometime in the next couple of years. But this was just me making a step in the direction of manufacturing the foam from home, which is something I wanted to do for years now. And this puts me a strong step forward. Doesn't mean I'm going to do it today. I think it's a big project. It's going to be an expensive project. And I just spent a ton of money on the robot already. And I don't want to now spend a bunch of money on something new right away. I need time to recover financially.